medallion architecture going from raw orders or raw data that's been generated here, the bronze layer, landing that raw data into a Delta table. So we're using Delta behind the, or under the covers here at every step. The silver layer, which is enriching that data. So going to be cleaning it up, doing some, rule enforcement on it. And then finally the gold layer, our presentation layer, our data mart layer for, the data warehousing parlance. Again, building aggregations, things that we need to actually have the data be consumed efficiently. That can be consumed directly in SQL Analytics. We're actually going to take in the second section using MLflow, which is our ML Ops toolkit to enhance that data, do some predictions on it, and then finally we'll be consuming that in the dashboard in the last step there. I guess we're a little ahead of time. A Q&A check. Is everybody getting their repo time? Looks like we were looking at some folks. I saw one person wanted to see again how to do the repo setup. So again, the last link that was in the chat, it should end with a .git. You can paste it in there. And then it should auto-populate GitHub here. It should auto-populate the repository name, and then you should be able to hit create repo, and then that code will be pulled down for you. So a lot of folks needing assistance creating the repo. I see some folks have already got it set up.
Hello. Yes.
Do you know about the error enter a remote Git repository URL?
Yeah, hello.
A couple of those.
Yeah, tell me.
No. Yeah, so I think that maybe some folks are using the GitHub link that ends with /retail. Okay. Don't use that one. Use the one with cloudlakehouselabs.git. That should be the one that's going to get you the repo information there.
I just removed the other link from the chat.
What about the interviews? I'm not getting any calls.
The .git link that everyone should use.
A lot of time now.
Git provider should be GitHub.
Yep, GitHub. That should automatically populate along with just by pasting the URL. The two other fields should populate there. Okay, I see one person saying the error that already exists. If the repo already exists, that means that I think you've successfully created it. Yeah, I think we've got a lot of folks that are, I think, okay, so now I think we're getting some questions around the clusters, so I will keep rolling here and we'll start stepping through the lab exercise. Okay, so we'll start out here again. We'll go into the workspace. You've got your, again, accessing your repo, Cloud Lakehouse Labs, the retail folder, and then the data engineering with Delta notebook will be our place to start here. And this will step through all of our stuff there. Your lab cluster should be available to you. It should be your lab cluster dash and then the username code you're given. So in this case, I'm 1131199. You should, I believe by the API, have it started up.
Yeah,
so you've got a lab cluster that you're able to attach to, and a lot of those were started up there as we looked at the compute there. So attach your lab cluster there, and it should be the appropriate runtime, and we'll start stepping through.
What is the solution then?
Exercise. So again, the data engineering portion of this is going to be heavily reliant on Delta Lake. We're going to be stepping through, raw ingestion from the files that or the data that we generated. We'll be putting it in Delta Lake tables in every step. Delta Lake is a Parquet-based format that lives, in online blob storage. We really leverage kind of the endless disk space of ADLS Gen 2 in the case of Azure to be able to, write to disk.
Okay.
And then Delta Lake is the format that allows some data warehousing principles on top of what is otherwise just a data lake, right? It's flat files living in blob storage in your cloud tenancy. Some of the things listed here, we're talking about access transactions, transactional integrity, the ability to do schema enforcement, schema evolution. An important one is time travel. So being able to write out and then go back to a point in time or a version of the table. We'll step through some examples of that. And then finally, some database-ish optimizations, things like z-ordering, caching, being able to do maintenance on the files to try to improve the performance. And we're looking to attain that data warehouse database level of performance with data lake fundamentals and economics under the covers there. So we'll start to step through that. All right, so I'm just going to start going through this. Most of the lab here, again, is self-explanatory. You'll be able to just take and execute the commands. One thing I forgot to mention here, kind of the core of the Databricks user experience here, and we'll be using this almost exclusively today, is the multi-language notebook experience. And so again, we've got the ability to go in and select available languages here. Programmatically, we'll be focusing on Python and SQL. Depending on your runtime, Scala and R are also options here. And then all the documentation here is again is provided by Markdown. So similar to those folks who might have experienced or had some experience with a Jupyter notebook a Jupyter Lab type notebook. But we do have the ability, and we'll switch in and out seamlessly between languages. We've got some ability to do some file system things and stuff like that. So again, really great flexibility in our notebooks to be able to do things, add documentation via Markdown, switch languages we could go through, and we'll show some examples of all of that. So again, I run the setup. It'll be important to run the setup lab. This run includes here, again, we're going to be doing that. We'll be using Python to start, and we'll be doing some looking through using Databricks utils to be able to look through just a raw directory that's been generated. And in this case, we have a bunch of JSON files. That's going to be our raw data layer. This could be application data. This could be streaming data. But in this case, we've got a set of flat files in JSON format as our raw layer that we're going to be putting through the different steps of a medallion architecture to cleanse it. I can do some Unix-like commands. Again, you'll see the % here to denote that we're kind of taking off from that. But again, in this case, we're running an ls command, and this is as if I were getting information from the file system. I'm getting information on the JSON, the size of it, some kind of like a ls minus l command that you might get on the Unix command line prompt there. So we'll start stepping through the raw data. Importantly here, I've got a % sign and I'm switching to SQL. Again, you do not have to stick to the same language for the entire notebook. In this case, I'm just denoting that I'm switching to SQL. I'm running select statement and I'm running it against a set of JSON files. And this is as simple as saying select star from JSON and denoting the physical path with which this is created. I'm going to do that, and I'm going to get a SQL query return here. Okay, so now I'm looking into the JSON files. It's scanning all those JSON files that I have here, and I have my raw data layer. I have a basic schema that's been inferred from those, and I've got a whole bunch of different fields in here. We're going to start by consuming this into the bronze layer, doing some cleanup, and we'll end up with a gold level table from this raw data set. Another important feature, and we'll see this, one of the things we strive to do with the platform is to make a lot of the hard stuff, in setting up a cloud-based environment with Spark to make that easy to do, in this case, streaming data. You'll see a lot of stream code as we step through here. We're all going to be doing this just kind of one time as we step through this example with the tool like Autoloader, which is something that we've got baked into the platform. You'll be able to run once to test. You'll also be able to set these notebooks up to continually listen for new data, and then it will kick off and run these different pipelines. We'll see a couple different ways to manifest that as we step through this. In this case, this cloud files is how Autoloader gets invoked. I'm working with some Python code here. I'm going to be reading in a stream, giving it a format. I want it to infer the column types. I want to tell it to write a schema out. And again, it will be doing some checkpointing. The key here in this test code is that I'm just going to trigger it one time. So it's going to execute once. It's going to pull everything in from the raw layer, and it is going to ingest and kick out a set of bronze tables for me to take downstream here. So I'll execute that, and we'll take some time here. Take a quick look at Q&As. Somebody, looks like people are getting in. There was a question about the commands that we're running. These, again, all should be available to you inside of the notebooks themselves. I'm just going to be stepping to the notebooks and showing a couple different places where you might need to opt out here. A question about what is Cloud Files. Again, Cloud Files denotes that is invoking the autoloader, which is our library for kind of continuous micro batch or streaming loading there. Shamblin, should I be trying to say answer live to the questions that I'm trying to call out here while we're waiting?
No, I'll try to dismiss those for you.
Okay, I'm just trying. I don't know what about Q&A management here. So, okay, so our bronze layer creation ran, and now I'm going to step back and I've got my bronze table. I'm again kicking back to SQL. I'm going to do a select star. And I've got SQL results. And again, this is just those raw tables, but now I'm querying a Delta table here. So I have my bronze layer tables, and I'm going to be taking them through the next step to get to the silver layer tables. And again, in the medallion architecture, there's a lot of kind of differing opinions about what data lands at what stage. Is it just the raw and then the raw layer? What are we doing as far as, quality or checks or whatever, doing any kind of roll-ups? There's a lot of flexibility there. The kind of the go-to thought I think of with bronze, silver, gold is raw, cleansed, and presentation. And that's what we'll be looking at in this activity. So in this case, silver, I'm going to be actually giving my columns some conversion to data types. So creating my timestamp columns into actual, timestamp data types. I'm going to be hashing the email column to, obfuscate that and preserve privacy. I'm going to be doing some casting to integers. Again, taking what is a bunch of, string text and stuff like that in JSON, and now putting that into a properly formatted database-like table. So I will do that. And again, I'm looking to be producing this churn users table at the silver layer. The chat list is running. All right, so that executed. And now my churn users table should be available. And I just want to look and see, I've got a more tightly tied, it's a timestamp column here. I want to make sure my email has now been obfuscated. So that's been hashed out to a value where it's not a concern there. I've got typecasted integer columns. Again, we've got all of our data. And also notably, we deleted a couple columns here. So I've gone down from like 11 raw columns to 9 columns in our table that we're going to be taking on to the next layer there. I'll run this next command to pull in the orders into a silver orders table. Again, the churn orders silver layer here, and verify that I've got information in that table. All right, so great. I've got my 2 silver layer tables created, and now we're going to actually go through and move on to gold. And I will be doing this. Another move here, this is kind of a little bit of trickery, but we're going to be executing Python in this gold layer table creation. I'm just kicking out and creating this one gold layer table, the churn features table. And we've got Spark SQL. I'm executing Python, but in it, I'm just wrapping, in triple ticks, wrapping a long SQL command. So it's another method of executing SQL in Python. And then I can switch back in the same cell to Python code to be able to do a display without. So I'm kind of wrapping SQL inside of Python here inside of this one. But what we'll be doing is, creating some stats, doing some different selects, rolling up aggregations. Again, gold is the presentation layer that we're going to be eventually taking forward to use for machine learning. We'll be doing these rollups here and placing it in one churn features table. So I'll execute that there. Q&A while this is running. But importantly, now I've got some enriched columns here. I've got some computed columns, Bayesian selectivity. I think again, these are now features that we're going to be looking to take forward into our machine learning application to do some predictive analytics on. I'm going to stop there for a sec just to look at the chat and see Q&A wise. If we've got any.
I want to address one thing I'm getting a lot of questions on really quick.
Yep.
This event is being recorded. You will receive the recording as well as the slides and the notebooks via email within 48 hours of the event.
Thanks for that. I think, let's see, the question that the Delta tables are managed. Yes, in this case, they are managed. So all the underlying file structure is being managed as well. There is an option to use external tables. So those are non-managed tables where just the metadata is being managed. In this case, if I drop a table, the underlying files will be dropped as well. With external tables, it is not that way. So it's a way to not have Delta manage that. Let's see, what are the different layers? There was a question of what part of this is autoloader. Again, the cloud files tag there is the way to denote that we're using autoloader. So it's just at the bronze layer. Again, they'll be pulling, say we're, having additional JSON files come into the raw layer. And then I want to maybe, configure autoloader to continue to stream in new changes and new files. That was the cloud files thing just at the bronze layer that we ran one time in this case. Do you have to go through all the layers? You do not. If you have a quicker step to do it, again, it's, kind of just in that idea that in a, the old ETL, we would go from raw to staging to the data mart or, the operational data store. This is a way to mimic that with raw to cleanse to presentation layer, gold, silver, bronze. The question around, got somebody answering that one. So there's some Delta questions here, which is good. I'm actually going to continue to step forward into the next section, which shows, you can see the header exploiting the benefits of Delta. So this will show a couple of the different Delta features and how they manifest themselves. And we can show some of that, and then we'll see if there's any more questions there. Let's see, some time to travel stuff. We can answer that after we move through this section here. So in this case, now I'm going to say, I'm deleting from a timestamp. Again, this gives me the ability to run a SQL command, and I'm deleting this timestamp. In this case, we're saying, this is a fictional compliance issue where we say we need to get rid of data that's older than, the 1st of January 2016. Now, with Delta, until we've done a maintenance operation, all of the data it continues to live in the file system. So these 94 records have been deleted, but they have not been kind of cleaned out, vacuumed away. That's, I think, there was a question around the time travel feature. The time travel is going to give you everything that's available on the file system until, pending like a vacuum operation, which is maintenance. I believe the default is 7 days. That is configurable to the different, configurable at the file level or at the table level there. Now with that delete, I'm going to look actually at the describe statement, which is going to give me the history of this churn users table. And now I can see the operations where I created it, I made a streaming update, and now there is a delete thing, and I've been given a version number here. So this will be one of the ways to go back in time, is to do a select as of the version. And this will go back and go against this version 1, which is just the streaming update without the delete. So this would include data that is older than that 2016 cutoff that we made. Now I wanted to say we didn't want to delete that information. We haven't vacuumed the data away yet. It is still available. I'm going to restore to that version. And again, it's going to just pull that back. And I believe once this runs, we got the restore operation, and I should see a new version of this in my history now where it has been restored. You can see version 3 now has been that restore, and it goes to the restore version. So information is available there on the history there. And again, all that lives there. Time travel is available to that. There's a question around optimize. Optimize does not remove deleted data. Vacuum should be the command that will clean up anything to a certain point in time. Along with that, we will look at the optimizing things here. So optimize, we're going to turn on auto optimize in this case. So Delta does provide, and we're constantly improving Delta to have more features to do optimization automatically. But in this case, if I want to do something akin to creating an index on a database table, I can do Z ordering on different columns. So I'll set an optimize and I'll say what columns to Z order by, and that will create an optimized table for querying where my my predicates in my query are going to be primarily these columns here. So that is the end of the data engineering one. We'll pause here for questions. Z order again is the way to do kind of column level indexing. So Z order is setting up, and it's handled behind the scenes with regards to how the file is managed. But setting up metadata to more quickly query the table, the columns that you've set up in your Z order. So I've optimized, in this case, the table around user ID, first name and last name with Z order, similar to a database table index. There was a question on what is liquid clustering. We're not going to cover that here in the lab, but there is documentation on it. Liquid clustering is a new feature in Delta 3.0, I believe, where there's doing some file optimization, being able to pull small partitions of data together, and again, to continually optimize to give, again, just better query performance behind the scenes with less work, less manual maintenance. The churn prediction, we're going to get there in the machine learning section. Auto optimize, again, runs optimized with kind of the best, does some analysis on the table and puts best optimizations out there. Another question on bronze, silver, gold. So again, think of bronze as, in this case, we're thinking about bronze as our raw layer. Silver is our cleansed data, putting some data quality rules in place to clean the data. And then gold will be optimized for query at the presentation layer. There was a question around talking more about data quality. In this case, we're doing a very basic data quality check. Again, we're doing some typecasting of columns and obfuscating, hashing the email address. This one was, the silver table for the users here. When you're pulling in from JSON, it can try to infer the data type that's happening behind the scenes there, but it's not, it's not a silver bullet based on the quality of the raw data there. So again, doing some typecasting, optimizing here, making sure that we've got integer columns, timestamp columns to be able to do the operations that casting into those data types allow us. That's what is data quality here. So very basic. Basic there. There was a question on rerunning Z order for optimization. You should not need to rerun it. maybe optimizing periodically using vacuum. But once the Z order is established, again, the metadata management that lives, kind of resides next to the data is going to be there with it. All right, I think time-wise, okay, I'm gonna push ahead into the DLT section here to show kind of the other flavor of data engineering, and also into the Unity catalog sections. I think we're good on time, and if there are questions, we'll try to resurface those around Z order and Delta at the end here. There's a question there about Azure Data Factory. That is something that integrates well. It's an Azure feature that integrates well for external orchestration with Databricks. We will not be talking about ADF in today's lab. And would time travel work after files have been vacuumed? It will work up to the vacuum timestamp level. So that, again, the default is 7 days. If you set it to 30 days, you can time travel back to that amount of time. But you will not be able to access data after it's been vacuumed off, if it's past the maintenance window there. There was a last question there. If we run cells partially not in sequence, there are some dependencies there, so you should try to go from the top to bottom with the flow of these labs. But you can rerun things if the objects have been created. You can run things out of order and that way. All right, I'm going to charge ahead here. On to the second section with data governance and Unity catalog. So again, now we're kind of switching over to a different persona. Again, this is where Unity catalog, I want to call out that Unity catalog is very much an operational and kind of security oriented data catalog feature. It's a governance feature at the operational level. It is not necessarily an all-encompassing, business-focused, business terms data governance solution. It's something that you're looking to control and have granular access over all the components and all the objects that live inside of Databricks there. And so we're going to go through just a quick example with now I've got the ability to go in and look at the data at the different layers here. We've got the catalog database, so the 3-tier namespace that we'll be stepping through, the catalog database and the individual tables. We'll be able to look at schema and lineage, but I want to now execute this. Connect back to my cluster. And we'll get some information, and then we'll take that information to the catalog option, which is up here in the corner, and look at the data explorer and actually see how this manifests itself. And we can show how some permissions are done there. So I've got, just for information, I've got my information here, the catalog, and then my schema that I'm working with. I'm going to keep getting information here. I can show the catalog, I can show the database, and then there are many databases available now inside of that catalog, each one, assigned to the individual users. We've got your user tag there. And then below that, the individual tables that we reviewed. Again, I've got my bronze, silver, and gold layer tables that I just created in the previous notebook. In this case, I'm going to now copy and paste, again, another one of the database fundamentals that we have is the ability to do grants. So in this case, we're going to be granting schema and table access to account users. So I'm going to go up here and pull my schema information. Schema information, not catalog information. And I'm going to paste in my schema here. And then I will select one table. I'm going to give the churn features table the ability. This is not going to have an impact on the lab, I don't believe, because we're kind of working on our individual silos here. But it does show how the individual grants can be given. So I've run that grant. I got OK. And now I'm going to go see how this manifests itself here in the catalog. And so I've got my catalog now in the Cloud Lakehouse Labs catalog, that top level object, we've got all of our different users that are in this workspace. It looks like a lot of folks have been able to follow along and create their own schema. And then, we've got the different objects here that are tables underneath that. And then importantly, I can look at the permissions. And now that grant that I just gave for use schema is available here in the database in the permissions tab. And then I'm going to go down a further layer to the features and look at the permissions. And again, I granted select to the account users for this table. On churn orders, for instance, a different table, it does not have any permissions. I did not do any grants for that table. And so you can see there's really, granular access control can be given down to the individual Delta table object. Another thing that is difficult to do in data lake management, the Lakehouse architecture that we have provides that. And then another cool thing about Unity Catalog is, again, once you're running notebook objects, I didn't do any kind of specific logging of the different objects there inside of my data engineering notebook, but lineage was captured behind the scenes. And again, you might notice that this mirrors our standing out here, mirrors what we saw in our kind of flow diagram about creating the two bronze layer tables, creating another bronze, but then our two silver layer tables, and having all three of those things populate into our gold layer table. So again, churn features, I can now look back and get column information where that flows back all the way in the lineage graph here. And that's all for free when you're allowing it to be managed by Unity Catalog. Okay, so that is the Unity section. I'm going to push ahead to the DLT, and I think that we're doing well on time, so we'll have some time to do some more questions after that. So, Delta Live Tables. Delta Live Tables is akin, but not totally the same as Delta Tables themselves, but it is a different ETL framework to, again, make, especially in cases where you're talking about streaming data and append only or additive layers, to be able to do kind of end-to-end streaming of data. Once streaming data is found, it immediately starts processing. It's sent through, and we're going to end up building a very similar pipeline to what we saw on the other side in the data engineering with DLT here, and we've got the ability to do that in Python or SQL. But again, we'll be stepping through and showing how that manifests itself here. There is a different interface for DLT. So we're going to be going through running this setup. And we'll run this command. Now, importantly, this is going to be one where we're going to be stepping out of this notebook. It's not just executing this notebook. We're going to be using some information we derive from this notebook. We're going to be going into the DLT interface to create a Delta Live Tables flow. We're going to be given that. And then we will be able to run some queries after that to be able to check the results of our DLT pipeline here. So now I'm going to go into Delta Live Tables, and I'm going to create a new one. Looks like somebody's already been in there. All this. We'll be creating a churn DLT pipeline here. I can leave this on advance. I want to leave this untriggered for now. I will be controlling the execution of it. One of the great things about DLT is that once the pipeline is constructed appropriately, it can be left in continuous mode, and it will continuously look to stream data in, process it through the silver layer onto the gold layer as we've got that set up here. I'm going to use my repo to go in, and I will actually be pulling in one of the other tables, or as one of the other notebooks. We're not going to be running that notebook interactively. We'll be pulling that notebook in as the source code here, and I will be doing that. And then I've got my Metadata, the parameters from the last one. Again, I'm going to be looking at the database schema that's generated for me. That's my schema. We'll be doing that. And I'm going to look at, specify the storage location. Again, I'm pulling that and copying that in. And an interesting thing and a way to just show the difference between these two things is that we will be putting it in the Hive Metastore. The Hive Metastore is our legacy metadata manager, but I want to use that to show the delineation between Hive Metastore legacy and the Unity catalog, which we just viewed there. Everybody should have access to a DLT cluster. So there's a DLT cluster there. And then I've got those parameters in here, and I'm going to create that job. Now, we're living inside the Delta Live tables, inside of our workflow space here. Again, a different interface for this. I'm going to start this, and this will take, I believe, several minutes, unless the cluster's already started. Here. Okay. Should be looking fine. Looks like we're getting a lot of failures here. Okay. I'm not going to try to troubleshoot that live here. Everybody should see that there's a DLT cluster available to them. DLT single node. And the folks that are posting that they don't have a DLT cluster available, post your workspace name. The DLT cluster policy should be available in all of those. All right, looks like I might have a little issue with the cluster policies. Give me 1 second here. I'm going to step through. I think I just need to do a quick permissions update on all the DLT cluster policies, which is causing this trouble. Hit by green the permissions. All right. 1 second. So I'm trying to step through for the folks. Give me just a minute here, and I think we'll be able to retry. I did see that there was a permissions issue with the DLT cluster policy that I'm fixing now. Just opening the last one. A lot of folks should be able to try to restart or refresh that page, and there should be a cluster policy available to you now. It should be available for all users. Just doing the last. Okay, so I've updated it on all spaces now. If you are in that page and you don't see it, hit refresh on the window, and the policy should be available to you. Okay, great. So folks are getting the cluster policy there. Apologies for the permissions snafu. Okay, no, this doesn't explain why my it is not going through here. So here's where after the refresh, the DLT cluster signal node should be able to be available there. I don't think I'm missing anything with regards to this. So it's working fine in my testing. I'm not exactly sure what's going on here. I'm gonna try one more. Okay, permission should be fixed. So again, if you're not seeing the policy, then you should refresh. And the answer is yes, you do need to create the pipeline. So we're going through that pipeline window. Okay, for folks in the first workspace, and we'll try it. I think I've got a issue with my cluster policy here. Okay, I had an issue with the cluster policy in the first one there. Sorry for the live debugging, but a lot of folks there. Now this will take some time to start up. There is a long lead time again, because this is using that cluster policy to start up a new cluster. So it will wait for resources. It'll take several minutes here, and then it will go through. Yeah, apologies for the stop there. What I want to do is show the underlying notebook that I created, or that I used as the code there. Again, we're not running these things interactively. We're taking the notebook and putting it into our DLT conversion, and then doing that. But I want to show kind of the ins and outs of the underlying code. So again, this is a DLT is a Databricks specific framework that runs behind the scenes. And again, we're going here, and again, on the SQL side of things, this is available in SQL or Python. With the SQL side of things that I'm showing here, importantly, I'm showing the create streaming table to notes that I'm going to be using DLT for this. I have the ability to add some language around constraints. Again, so this is doing some of our data quality for us here, but it's going to be stepping through and essentially doing the exact same thing that we did with the other manual pipeline, where we interactively went down and did all these steps. So I'm going to be going here, as again, similar, doing a select. I'm hashing my email. I'm stepping through and creating timestamps. I'm finally going down, building an aggregation here. And again, creating the gold layer table to the end. And let me go, I can check on my pipeline. We're still waiting for resources. So let me quickly step through back. And again, that's how it manifests itself with the SQL syntax. With Python, again, we've got a DLT Python package. So we're able to pull through and do a bunch of DLT specific features using that decorator there, the add DLT decorator. So we're doing this, defining functions. But again, there is an API to get into DLT either through Python or through SQL. But again, I'm not running this notebook interactively. I'm taking it after it's written and putting it into a DLT pipeline definition, and then executing that pipeline, which goes against the Delta Live Tables runtime there. Let's see, it's still waiting. I'm going to see where we're at with questions here. It looks like some people are successful after those updates. Same example of, I think there was a couple of folks that were looking for some additional, or maybe let me just quickly retread on how to create this here. So again, I was pulling from pulling metadata or parameters from the 0.1 or 01.2 Delta Live Tables notebook. I ran this parameters job and got the schema and the storage location. And so when I want to go and create a new pipeline here, this is again the form that we're doing here. So again, I'm going to give this a name. I'm not going to create this one, but this is not a specific name you need to do. It can be arbitrary. I'm going to leave this as advanced. I'm going to leave this as triggered because we're only going to be doing it one time. And then importantly with the path, again, I've got those two flavors of notebooks. So I'm going to be stepping through to my repo and then grabbing either the Python or the SQL one. I think I went over that a little too quickly the first time there. But again, I can pick either one of these. It's going to be the same underneath the covers, or it's going to be the same output. So I can select one here. I'm going to leave the Hive Metastore as my storage option. And then I'm going to be pulling in the parameters from this to the target schema and the storage location here to the storage location. Cluster policy, again, I think this is where a lot of folks are getting tripped up because I didn't have the permission set correctly, but this should be DLT cluster single node. And then you can click create and your pipeline should be available for you. Let's see how I'm doing with my DLT pipeline. Still waiting for resources. Okay. Let's see where everybody's at with there. Yeah, waiting for resources. I think that there's going to be a lot of waiting while these clusters are being spun up in the background. Unfortunately, with jobs, these are things are spun up and created. I'm seeing some progress on mine now where it's initializing. That means it got resources. But again, on a job start, you have to wait for the VMs to spin up that is going to power your thing there. Looks like some people are completing. You should not need to delete the pipeline or you can read the parameters. What you can do is go into settings and that should give you access to that. If you have incorrect information in the storage location, that's not editable after the fact. So you will need to go and create a new pipeline. And again, it's just mostly about making sure you have the correct notebook selected. So making sure that you've got one of the two Python or SQL notebooks as what you're executing there. And then should be good to go. Cancel this. So now we have a complete run. And again, now I have the benefit of having that, the directed acyclic graph, the DAG generated for me here. So I've got streaming table on the different sides here, but again, we've got that bronze, silver, and gold. I'm looking at, similar lineage to what I was seeing inside of the thing created there. Okay, so try to close out here. I want to go back to my table now, and I'm going to be able to actually run against the tables that I created in the Hive Metastore. But again, notice that I'm going against the Hive Metastore instead of my Unity catalog manage catalog. I can get information here and go through there. I will rerun this now to show how the history manifests itself. Again, it's the triggered one. I'm starting. The resources are already available, so this should be much faster this time. And I'll actually be able to show here how it steps through from left to right, the bronze, silver to gold once it's there, once the graph is being rendered. So again, I've got my upstream processes running, and then immediately when the dependent processes are done, these different things will kick off there. There's a question about if DLT can be used for ML workspace and ML flow. It can be used to populate underlying data. It is not, the DLT runtime is not an ML runtime, so not all of the ML packages and things like that are installed. Our interactive cluster that we've been using is an ML runtime, and so as we step into the ML section in the next hour here, we'll be using that and not a DLT cluster. There's somebody who's saying they still don't see a DLT cluster. Could you, if you're not seeing a DLT cluster policy, will you post your workspace number or workspace name? So it'll be labs and then a 5-digit number. DLT, there's somebody asking about DLT pipelines. So the DLT pipelines in the left nav is the Delta Live Tables option here, which is what DLT is short for. Okay, so Rihanna, let's see. Just checking the compute for the one. If you're not seeing it, I think that you should be all set up right. So if you're not seeing it, you've been on that same screen, try refreshing the page. It looks like it should be set up for all users to use inside of all the workspaces there. Let's Yeah, it's looking like all the ones are there. Again, it should be a DLT cluster policy. It should say DLT cluster single node in parentheses on that configuration page. This is where it should be manifesting itself here in the cluster policy. And I believe that's been set up correctly for all environments now. How to determine if it's a delta table, someone asked. There is a way to do that in the browser here. So I can go in and look at my different tables. And I'm going to my schema here and look. And in this case, I can see that the source format is delta. So that's an easy way to check at the catalog level. There was a question about a vanilla delta table versus delta live table. Think of, again, delta live tables as a table that is set up for that streaming infrastructure to be placed around it. So it's created with different syntax, and then it's meant to be serviced by DLT pipelines. You're not going to be running against DLT tables in interactive clusters and things like that. I don't actually know how many DLT pipelines can be in a single workflow. You can add many different notebooks, and it will manage all the interdependencies of those notebooks. But I don't actually know if there's a hard limit. There probably is a limit out there, but I don't know off the top of my head. The question on the DLT pipelines, if they get deleted, if the DLT pipelines get deleted, the underlying tables should be there. They should still be queryable. But the other pipelines that service them will go away, obviously. Okay, time check here. I think we are on time to step into the machine learning section. If you're having trouble with that, with the data engineering portion, hold tight. We'll try to step through the machine learning section in the next 40 minutes here, and then I'll go back as we're able to try to take questions. Okay. So I'm going to be going down here to the second section, O2, and then building an example for data science. So our machine learning toolkit, MLflow, will be kind of showing how, Databricks' opinion on what we do on the platform. Again, data science, for those practitioners that might be in our cohort here, they really have a lot of tooling that goes. What MLflow aims to do is to be able to wrap all of the popular machine learning frameworks to be able to provide experiment tracking, repeatability, feature store durability, again, kind of wrap some of the difficult parts of machine learning operation management, putting those into a different set of things. And what we'll be largely living here in the machine learning section as we go through experiments, feature store creation, model registry, and we'll talk a little bit about serving as we go through here. But again, now we're thinking about switching to a different persona. Mark is our data scientist. In this case, the data engineering has been done. We'll be using our churn features table as our feature set. We'll be going through kind of standard machine learning practices here, building out. We'll do it manually first, and then I'll show an example of how AutoML, which is an automated way of generating best machine learning notebooks is done. Again, all just kind of baked into the platform here. Again, so the thing to remember here, we'll be using open source libraries for the machine learning components. We've got MLflow plugins for most of the most popular machine learning libraries. So it's not trying to reinvent the wheel with regards to the underlying libraries. It's meant to be flexible as much as possible, and then just put experiment tracking, notebook, registry, again, some governance and some operations flow around it, and then being able to go all the way through to serving the models very easily, either in a batch or a real-time inference model. And so we'll show some examples here, but we'll be stepping through a notebook that will all be going through MLflow. We'll get some nice stuff around stats, publishing, being able to maintain different information around the models. Again, it's trying to make some of the steps of model training all the way through to serving a little bit easier to do here. Okay, so I'm going to go and use the Hive Metastore tables that I used in my DLT. So to do this, you will need to run the setup. I will need to have my DLT tables completed from the previous step there. So as you have that, please continue to work through. For the folks who have joined late, the good way to start here is to look in the web chat, and I'll repost this if you're trying to catch up. I've just reposted the GitHub information for the repo. So take that information, new repo, and paste it in here. That should get you a repo and the code that we're going to be going from here. We've now stepped down to the second section for machine learning. All right, so I'm going to step here. That's worked now. I'm going to be creating some variables for my churn features table. Again, I'm using my gold layer table as my data source for this machine learning exercise. And now I'm going to be using Seaborn to do some visualization. Again, we've got complete flexibility with the ML runtime to be able to pull in any Python package we want to do around data visualization. So I'm able to do some analysis on my thing here. Again, I'm not going to go into great detail. We're going to try to move quickly through this, but being able to give visualization to do, feature, if you need to do feature reduction or any kind of analysis on the feature set, to be able to do that, we'll be able to get flexible visualization at the top or at the front here. And then I'm going to go and use now start working in pandas. For those familiar, we'll be using actually a pandas API. So it will be giving pandas-like information or pandas-like interface to Spark. And so you can see here, we've got pandas API on our churn data set. And what will end up looking like is a pandas data frame as it's outputted here. So I should get a pandas-like view as I come here. So those familiar with pandas, this looks very familiar, where I'm getting, a pandas data frame type structure, but it's all Spark working in the background. All right, and then now I'm going to be tapping into the feature store. So the feature store option is available down here in the features. We've got the ability to pull in the feature store client. That's a Databricks library, but again, this is kind of the Databricks platform, MLflow feature store, and I'll be able to do that. Feature store does have Delta backing it, but there's an extra layer of kind of metadata management and durability behind the scenes here. So a feature table is not exactly like a Delta table. I'm going to let my feature store correct and run here, and then I should be able to access it in the features table. We can see several people have been able to create it here. I've got my table at the top, and I'm able to go in. Again, there's a lot of information here around the feature information. There's even information, where is this being used, what models are using it, what jobs are using it. Again, additional metadata that kind of wraps the entire thing to make transparency and collaboration easier in the machine learning space. So I'll close out here, go back to my feature table. All right, so now I'm going to step in, excuse me, I've got feature creation completed. I'm going to move through to doing model training, and we'll see how the models manifest themselves with experiments and the model registry instead of MLflow. Like I said, there are many ways to be able to do machine learning. In this case, we're going to be just using scikit-learn, one of the more popular Python-based ways to do this. We'll be using test train split to create our test and training data sets. And then I'm going to be stepping through doing some, column selection, some imputing, some one-hot encoding for the uninitiated. Those will just be moving kind of standard steps in the machine learning data preparation to be able to do model fit, model training. We'll still be stepping through some of these things quickly here. But for those familiar, looking to do column transformation, imputation, and then one-hot encoding down here again, filling in missing values in our numerical columns and being able to one-hot encode our sparsely populated categorical columns so as to be able to balance that out and use those as part of our model training. All right, I've done imputation there, and now I'm going to one-hot encode. That should not be. Fine. Sure. Anybody on from the Databricks side know why this might not be working here? It should be fine.
Don, it looks like someone has posted a resolution to this. It said this fixed the issue on hand from sklearn.preprocessing import one-hot encoder. Does that make sense?
Yeah, that's exactly what I was hoping. I didn't know if we won't run afoul not having the right one-hot encoder. But Eric, I see, posted that. Thank you, Eric. Okay, so I'll post this in the chat here. We've got so if there's anybody who's getting an error on that import on the first line, I've just posted that in the chat. Replace the line that says from AutoML sklearn with the sklearn.preprocessing one-hot encoder, and that should get us where we need to go. Thank you, Eric, I believe you were the first to post that. Right. So now we're going to go through our transformation process here, and we're going to apply our encodings onto our test or training and test sets to get our X, Y, and our X and Y train and test sets, and then really kind of get into the important block of code here to do model training. So notably here, the MLflow library is being imported. We're importing our different functions that are going to be able to register the model and to be able to reuse the model across model serving. In this case, I'm going to just be using a random forest classifier. Again, that's just a popular scikit-learn operation here. We'll be putting into a pipeline. I'm going to kick this off and let this run, and then I'm going to see if we got questions here. The feature store table, it is not just a table inside of Unity Catalog. We are moving to have it managed by Unity Catalog. But it is, again, there's a bunch of additional metadata, additional linkage that's there and available in the feature table. So it's, like I say, it's a Delta table plus some extra machinery there that makes the interconnectedness and collaboration and sharing of it, reusability of it, a better process. I believe the recording will be shared after we're done here. So.
Yep, that's right.
It's the final one of this. Well, my model fit unfortunately is erroring out here, and I'm going to need to look into that as to why. But I did want to call out that because of MLflow being called here, we've got a start run, and we've got this stuff rolling in now. An experiment was logged, so I'm able to step into the experiments option here, and I've got experiment runs. I got my experiments that I've run here. There are other users running here, but in particular with mine, I can see the different MLflow is logging each activity here, and I can link back to the source. Again, MLflow is doing a bunch of documentation, a bunch of logging with the idea of, if it needed, to be able to step back and recreate a machine learning run, a machine learning experiment at any stage in the game. Okay, I've got some folks. I think this might be downstream of that one hot encoder switch, which is. One sec here. I'm trying to fix that. Okay, one hot encoder, handle unknown equals ignore. Okay, I think the reason we chose MLflow for the question is that it's again, it's a Databricks open source project and kind of baked into the platform. So we're showing, kind of a key core platform tenant and using MLflow there. Thank you to whoever posted the note around switching. So switching this one line 10, they've got ignore, switching from indicator to ignore. That should get us where we need to go, and then rerunning these frames will get us to, I think it's models training right now is running successfully, but we'll take a couple of minutes. So for the folks there, we've got command 22 inside the notebook, switching from one hot encoder handle unknown equals indicator to ignore line 10 of that command 22 block. And then rerunning the subsequent commands will get us to, it looks like, a successful execution. Right?
John, if you have the ability to copy and paste that in the chat, it seems like a bunch of folks have that.
Oh, that line?
Yeah.
Okay. Okay, so we're going to keep pressing through here for sake of time. I'm now going to go look to register the model that I just trained inside of the model registry. So I'm going to execute here, and I was able to register the model that I trained, and I'm going to go now into the models option here, and should see my model version 1 that I just trained here. We'll just kind of step through this here, and then I'll try to take questions as we're able for the last little bit of the session here and try to monitor Q&A. I'm going to focus on questions. All right, so now I'm going to look back here. Again, I've got my model registered. It's going to be able to do versions of it, but again, I can go, and again, this is MLflow providing that that good documentation, that good logging around this. What features am I using? We're doing that. If I step back to my feature store, it should now have information that I am using that in a model. It's not. I don't actually know if I can zoom up feature table here. That's supposed to be populated. But what I want to do is have these models, and you can do this version line. I see that some folks have already stepped through, and then there's the additional layer of tagging available, that there's a stage available. And in this, we're able to say that there's a stage that's currently equal to none, but we can add some documentation to push it to the staging level or to production. And that is just communicating those folks inside the system that they can use that model to go for it there. So now we will say, I'm going to look and pull in the model version, version 1 here. I'm going to take version 1 and I'm going to set the stage equal to production. So this should go here. And now if I go back to my model and refresh, it should be marked as production here. If I rerun the experiment, we'll do that. I'll show how this manifests itself with AutoML here in a second, but more versions can be added, and then the metadata can be altered to say I want to use this version. And again, it's more not reinventing the wheel with regards to the underlying machine learning frameworks, but adding that layer of documentation and collaboration. That's what MLflow is really up to here. That's the purpose of registering the model for the person who asked it there. Again, kind of publishing, being able to look at it, reproduce it, get it, be able to write documentation around it, tagging, again, a bunch of information. When was it pushed to production? That's the idea of being able to publish and then push out there. Register rather than publish. But okay, so now we're actually going to step through again, kind of with similar to the standard and then DLT. We're going to be using AutoML to do a short thing here. So I'm going to go click New and do an AutoML experiment. I've got my cluster, and now a lot of what we did inside of code, inside of that notebook, will be made very easy just to specify these different things. I'm going to, give it a training set. I'm going to tell it what column I want it to try to predict. I'm going to look and give it an experiment name. But what we'll do here is go and look for my features table. I want to use churn as my target. It will auto create an experiment. And then what I want to do here, what AutoML is going to do is really try to just throw the book of, different techniques at the problem. So what we'll do is I say, use all the different training frameworks here. I've got like GBM, sklearn, and XGBoost. You're able to add more in there potentially, and then run a bunch of iterations of this, create notebooks, and do it within a time window. So I'm going to give it 5 minutes. If I gave it the 2 hours that it asked for, I would probably go through and really cook through and give me the best notebook according to the F1 score in this case. So we'll start MLflow there, and then this will continue to refresh. I'll come back and do this in a little bit here, but AutoML is going to go. It's going to start doing training. It's going to give me a timer that it's counting down to, and then it will start creating objects, creating notebooks, creating executions here. For this person that says that they're needing, can't see registered models, that should have been a step to run this register. So after doing the model training, you've got a model object available to you, MLflow model, and then you're tagging the client to actually register the model. So you'll need to execute command 29 to register the model inside of MLflow, inside of the model registry. The workflow and model we created, we've been doing this all interactively through the, just through this number 2 notebook. So if you've got the DLT set or the DLT table, churn table created, this, stepping through this workflow got a couple of code tweaks, but this should be able to step through, do the imputation, do the one-hot encoding, and then move through to, test train split and actually fit the model there. I was having some trouble with the people are saying copy from chat. If you select it and then it doesn't like the, maybe the webinar chat's not the active window. So right clicking and hitting copy, that's how I was able to copy and paste into the webinar chat window if it's not the active one. I know that it gets a little finicky as a thing there. If you, I think we're saying select all, if you have to drag and highlight some text, and then copy should be available once you got highlighted text. Yes, if you're doing AutoML, you use churn features as your training set, and then we'll use the churn column as the prediction column. So I got my timer here. It's counting down, but now I've been offered up some options here to refresh. And again, it's going through a set here. It's going to be using, like we said, different scikit-learn. We've got decision tree and random forest. It's going to be using XGBoost to that extreme gradient boost machine learning example here. And as my time goes, it will go and it will actually be executing these things. It'll be generating notebooks that I can look at. It will be eventually providing me with an F1 score. And then the one with the best will rise to the top. And then I can take and, if nothing else, it is not necessarily going to give you everything that you need in a machine learning pipeline, but it will produce really nice boilerplate code, and it will reproduce all the different steps that we move through in our machine learning notebook to do that. I believe churn is what you want to select for prediction target, the question out there. No, I'm sorry, Leanna, I can't copy out of the chat. So here we're starting to see some results. I've got, XGBoost looks to be providing the best F1 score, and I can start going in. It's got the different models there. It's going to be giving me some additional results, and it's going to use up all this time. And then once this 5 minutes is up, it'll try to clean up and show me, again, what rose to the top as far as that goes, and I'll be able to go in and review that notebook code and do that. So we'll just give that another minute. You can see I did move through that quickly. So again, with creating the AutoML experiment, selecting cluster, you'll want to select again, in the Hive Metastore, selecting the churn features table. And then the prediction target is churn. Should be available there if you got the correct table selected. And then again, make sure that you go to the advanced configuration. And if you want to have this thing run to the end and not run for 2 hours, I recommend cooking that down to, in this case, we did 5 minutes so that you can get something back in a reasonable amount of time for this. So I'm gonna look at my experiments again. We've got my MLflow experiment that's going. I should see that it's coming up to the end of its run. It is now done. And I can evaluate. Okay, so at the end of my AutoML run, the XGBoost was the one with the highest F1 score, and I can click through immediately to see the notebook with which that value was derived. Again, this is going to give you a really nice boilerplate. It's going to, pull in all the things, data loading, creating, showing the head of the data frame there, looking for supporting columns, doing date time, numerical coordinality. So all of our imputation, all of our one-hot encoding, that was all generated for us automatically in the pursuit of getting down to doing that. Test string split, it's got a validation set additionally for using that. But in this case, now we're pulling in the XGB classifier from XGBoost. And again, it's going to be going through and doing all the model creation. Again, I didn't have to do any of this. AutoML just took care of all that boilerplate code for me there. Doing some hyper opt search space here. So again, looking to do some hyper parameter optimization using hyper opt. That's all just kind of given to you for free. It goes through, runs some trials, tries to do some tuning there, shows it. But again, very nice to be able to have all of this just automatically generated through AutoML and then registered with MLflow. Everything is cooked and given to you for that, for repeatability, for things around feature importance, going through. All of this is just automatically outputted there. And I used F1 in the case of this experiment, but if I go back to the experiment itself, if I go to create a new one, you know, depending on whether or not you're doing classification or regression, the metric by with which you want to do that might differ. So if I'm looking again at my target, I'm just going to redo this one more time, looking at my features. I'll select churn as my target. But, you know, in this case, if I want to do accuracy, ROC, AUC, precision, you know, whatever you're looking to accentuate as the good metric with which to judge, we've got some flexibility to do that with evaluation as well. The question around AutoML experiment uses the model. So the model, it would run a series of different models because it's using different, it will create a series of different models using those different types. Let me see how that manifests itself here. Yeah, so it hasn't registered anything into our old model there. We would need to configure it to, and we could do that where it's, you know, saying use this model registered, or sorry, this registered entry, and then version the model. If you rerun a bunch of times, it will create successive versions, and then you can start, you know, tracking how the different evaluation metrics are done there, and go from there. All right. So we've moved through to the end there and done that. Now we're going to switch and finish out on the enhancement, and we'll actually create a table, or sorry, and create a new table that has it's been enriched with our model now to have kind of use batch inference to populate a table here where we've got churn prediction. That's going to show a prediction column at the end where our model that we've just trained will be used to, you know, put a binary out there and again show an enhanced analytics, you know, predictive analytics column in that. So I'm going to step through in 2.1 here. I'm going to quickly look for the production. So again, it's looking for in MLflow, looking for the model that we just trained and looking for the production version. So in this case, it will only take what we've tagged as a production model. It's going to pull that model and register it as a Spark UDF. And now I've actually taken my churn features table and, you know, with column turned it into the churn prediction table, and I've populated that, you know, using that UDF that I just registered, which is the output of my model, the predicted thing. It's going to apply that into a new column and create a temporary view called V churn prediction. So again, I've just created a temporary view there, and now I'm going in SQL to create this churn prediction table just as a select star from that temporary view. Now I should be able to have the churn prediction and should select from it. And when I do, a predictive column of churn should now be available to me. So I see my churn features table, all the same data here, and then all the way out to the end, the churn prediction column is now showing a binary value if the model thinks that that customer is going to churn based on all the features that go in there, the predictions made there. Clay's asking around productionalizing the top performing model. I will touch on that real quickly here. So in this case, this would be an example of that. We're creating a gold layer table that's using batch inference, you know, generating that column and writing it out. In the case, so, you know, an example there of batch inference. We can also do this in the model registry for doing real time or batch inference there. And then this is as simple as selecting your model and selecting use for inference. And then I can set up the ability to pick a model version. I can set up, you know, an endpoint name. I can give it the compute. In this case, a cluster will be created that will then provide an API endpoint to call that model and do real-time inference. So that will allow to be done there. We can stream it through DLT, and in the case here, we can also set it up for doing batch inference through this, not through a notebook. So setting up a table, putting out an output table location, and this will be a way to do batch inference. Again, you're writing out all the results to be served rather than hitting that model in real-time fashion. All right, running up on time for the ML portion here. I think got churn. There's a question on what churn means. So churn is data specific in this case. We're trying to predict whether we're going to kind of lose customers in this case. So that's what we're using. Customer churn is a very popular machine learning way to to use predictive analytics there. Clay's asking around, can you save the model as an artifact to use in custom scoring code? I'm not exactly sure what you're asking there. I think the models again are available, registered, and the different models. You can go in and look to look at the underlying notebooks. So the different experiment, the model is going to be tied to an experiment execution, and then MLflow is going to trying to provide all the notebook code, all the kind of ancillary documentation. It's creating a number of different automatic confusion matrix, some outputs there to be able to make it reproducible. So that'll be a way that you could pull that code out and execute it there. I think if that's what you're asking. But if not, we can touch upon that at the end. All right, we're right up on time for the ML section. So I'm going to jump into the final section around BI and analytics now. All right, for this section, I'm going back to the third part of my Lakehouse Labs. So I'll be going to section 3. And now, we're saying that we've moved from our data ingestion through engineering. We've enhanced the data with predictive analytics with our ML model, and now we'll be setting up some SQL queries and some visualizations inside the tool to be able to, give kind of SQL-only users. We'll be working through the SQL experience here. To be able to do that, we'll be working through the SQL editor, creating queries, and then using the queries visualization objects to create dashboards, and we'll come up with a nice visualization pattern that consumes some of the data that we just created there. So this one will be a little bit of copy paste, but it will be setting up some stuff here, getting a little bit of metadata, and then we'll move over to the SQL editor view here. And again, this just gives me information about where I need to pull my table from. And so I'm going to take these individual queries and I'm going to step into the SQL editor. And again, this is meant to have, for the folks that are not data scientists or not programmers, who might just be SQL analysts, to give them more of a classic database SQL developer view into the data that we're creating here. So I'm going to start taking here. I'm going to start with my total MRR, and we'll start creating these queries. We'll start executing them. And when I do this, I want to make sure that I select my data store, so I'm selecting Cloud Labs. I'm selecting my catalog and schema that I'm running from here. And then I'll execute this. This should give me a result set here. So now I've got the raw results as I would expect from a SQL query. I'm going to go one step further and create a visualization. We'll be doing this a bunch of times. So if we miss it, you can see this, we've got this bunch of times here, but in this case, a simple counter for that single numeric field. Find it. And then I can insert a label. And this will be one of the objects that will then end up placing inside of our dashboard. So I'm going to save that. And this will give me an opportunity here to name the query, and this query itself is going to be saved off as an individual object. You know, it's outside of a notebook. It's outside there, but again, your query text and your visualization configurations will be stored in this object inside of my workspace area, which I can then reference later. And I'll just kind of step through here and create the other queries that are mentioned inside the notebook as I just did there, and create some additional visualizations with those. So folks can, you know, again, copy, create new query, paste your code in, and then make sure you've got the appropriate catalog and schema created here, or sorry, not created, but selected. And then this will give you the code you're looking for. I can create a visualization. I think in the first two, we've got counters, then we'll create some charts. And I can step through and create these. I can rename and save. And again, now these are different objects that are going to be going in. There's a question on migrating dashboards here. There's not really the option to do that. The dashboarding feature is, you know, kind of built into the platform. You can certainly import, you know, copy or import query syntax here, and then build visualizations on top of it. But there isn't really a feature to be able to pull in any external things. We will touch on here in a minute. You know, this is the inbuilt dashboarding feature. It is, you know, it is what it is as far as how complex it is. We do have really excellent integrations with more robust tools like Tableau and Power BI, which we'll touch upon in a minute here after we go through this exercise of dashboard creation. All right, I'm going to continue doing this. Create a new query here, customers at risk. Make sure we got the right window. And for the customers at risk, I'm actually going to step through here. I think the also counter. Right, and so now I'm going to start moving over here, and this is an important one to call out again for 4 and 5. Switch over to use the Hive Metastore. We'll be pulling the Hive Metastore DLT created tables for those, but in a similar fashion, you can create a new query and then select the Hive Metastore and then your DLT schema there, and then, you know, be able to run queries against that. I believe this one we want to create a bar chart. Okay. So again, you know, creating a chart here where we're looking to see how many customers are churning based on the number of days since they created their account in this case, and we're able to stack and put different columns next to each other there. So creating a bar chart there. And Name. And keep reading these. Sure, got my next schema selected. The question, where are the queries saved to? So that's saved into the control plane there. Again, they're just kind of first class objects inside of my my workspace. So as I create queries and I access my workspace, I can now see the individual query objects inside the top level home object there. There's a question around drill down reporting. Drill downs, I don't believe we've got. There are some query parameter options. You can put like date ranges and stuff and parameterize the queries. But as far as the kind of interdependent drill downs amongst visualizations, I don't believe we have that in part of our dashboard feature. Yeah, one of our features. Create some more graphics there. Round out my set of queries. Right. Shannon's asking, there is a way to set the default schema. There is. Arthur's got your answer right there. We're using a couple different schemas here, which is why I didn't just I'm specifying with each individual one. Check it there. And commit. And one thing I didn't go into here, but there is there are several ways to kind of dress up. You can go through and I can do some stuff around stacking if I want to start doing stack bars. Each individual thing has the ability to color a little bit. If I want to name the columns to give a little bit more readable thing rather than the default. I can again do that. And so now I have a set of individual queries, but they also have visualizations tied to them. And now I'm finally going to go in and create a dashboard with these different things in there. So again, looking at the dashboards object here, I'm going to create a new dashboard. I'm going to give it a name. One thing to call out here is that we actually will have a SQL warehouse attached to this. We've been talking about the DLT clusters, the interactive ML clusters. There's actually a serverless SQL warehouse, which is again is a very specific SQL only runtime, and a way to use kind of a more purpose-built runtime to be able to do just SQL queries. That's what we'll be using in the background here. So I'll start looking for my visualizations to add to this thing, and I'll just start taking in, selecting the counter, and start adding things into the dashboard. And now I get kind of your standard dashboard gridding option here to be able to add in my different visualizations that I created in the query objects. A lot of queries getting made here. Let's see if I can. And again, I want to make sure I select the visualization. You can attach more than one visualization to any query. So if you want to, create and save a visualization with that, in this case, I've just created one per, and I'll start taking those individual ones in here. A little time check. Very good. And this would be quite straightforward if this was loading a little bit faster, but we'll just be pulling in the individual visualizations we just created, and you can start getting an idea of that. Question around, can you format any of the charts? That each chart has its own formatting options, which are available in that that wizard that we looked at. Get our bar of customer tenure. It's going to keep pulling in the individual charts and graphs and counters that we had there. There's a question if it's possible to export the dashboards into other workspaces. I believe you can, move the query code over, but there will be the need to, run that query against the underlying tables, which are, likely available in that workspace. There's some more advanced stuff with a feature that we call Delta sharing to be able to share out and be able to do that. But again, outside of using Delta sharing, something like that, the export import is not really an option for that question. You can see here that I got my underlying query. Must be some issue with it. So a nice thing to be able to do here is that any one of these things, again, this is a visualization attached to a query. This looks to be good. It looks like maybe I didn't save this. And so we can go back and see if that works. Okay, so again, making sure that the underlying object is saved there is what got me in there. And I'll get that pie chart that I created. Nice. Get that included here. But just to highlight, if I want to add any kind of, text, I could say, markdown formatting here. So this again is accepting markdown, and I can, do that to again, do a little bit so I can give some text to be able to do some documentation around these things. I can move the different objects around and be able to place them anywhere on that grid, the different objects there. If I want to go and modify the underlying visualizations, they'll be reflected back onto the dashboard here. And then when I'm done, I can say that I'm done editing. One of the things with dashboards, again, the underlying queries, this is going to be something I can add a schedule to this if I want to have the queries executed at a standard time, or in the case of the queries can run quickly, maybe a manual refresh here would be totally fine. There is access control for the dashboards. They are another object that is underneath Unity Catalog. So I've got my dashboard here. There was a way. There is a method, the underlying query objects, and being able to see those will kind of dictate whether or not you can populate the dashboard object there. I don't have the exact permission screen ready to go. All right, we're coming up towards kind of the end of the demo time here. There's a question around editing and visualization once created. Once you can do that, you can go into the underlying query object, and then you're just going to modify the visualization object itself. So again, we've got query, and then each query has one or more, or can have one or more visualizations. So to modify that, just as simple as going in here and making a modification, and then once the dashboard's refreshed, the modification you made to the visualization should be available there. All right, and then so finally, to tie it all together, I'm going to step through kind of the operationalization of all three steps that we worked through today, and we're going to be doing that via workflows. So let me close down here, and I'm going to go back to my last notebook inside of my lab code and look at the orchestrating with workflows thing. So what we'll see here, a lot of the workflows and the kind of the DAG structure from DLT are somewhat similar, but we'll see a lot of the ability to do that. DLT was all defined in a notebook, and then the chart was generated from that. With jobs or with workflows, we'll be able to go in and create dependencies and to be able to do monitoring run of the individual steps. In this case, what we'll do is we'll pull in all three steps. We'll run our ingestion pipeline that created our table. We'll create predictions. Pull in our machine learning notebook, and then a refresh command to say, now that I've created all the underlying tables, refresh my dashboard. And I've got my last output in the chain there. So I will step to workflows and create a job. And now I'm just going to step through and create my first task. So I'm going to say churn data ingestion. going to take from a notebook there and select my notebook. And again, I'll go to my repo, find my repo, and look at the data engineering with Delta. I'll be assigning a cluster to this. In this case, we've got a jobs cluster. I could run it on interactive, but in practice, the jobs runtime is always going to be cheaper and more efficient. So again, when testing, the interactive cluster is going to give you kind of the more verbose, larger runtime there. But as you operationalize the jobs, the rule of thumb is to always go with a jobs cluster and go from there. So I will create that job. Let's say churn and churn ingestion. No. All right. So now I've got my one job here. I can add a task. In this case, it's going to be another notebook. As you can see, my downstream thing is downstream dependency is automatically managed there. And I'm going to use another notebook. I'm going to again go, and in this case, use my machine learning notebook. Again, in this case, I would need to, because it's doing ML, I would need to run it against an ML cluster. We need those additional libraries and runtime in there. So in this case, an interactive cluster would be needed. And it's got the upstream task there. So it's making sure that that completes first. If I don't want that, I can delete that. But in this case, I do want to make sure that I've got that step that it depends on. So again, I will say, what does it depend on? This is flexible enough to say that I need to have multiple steps complete before a downstream step complete, or one thing kicks off a number of different downstream objects. In this downstream objects, excuse me. In this case, we just got a pretty step flow that we'll have here. And then I'll add another task. And in this case, I'm just going to say SQL dashboard. And I'll take my dashboard type. I've got my churn dashboard. So there's a bunch of other objects here. I'm going to select a SQL warehouse to execute it against. And again, I can specify if somebody needs to be notified when a dashboard is done there. But again, I've got my upstream dependency, and I'll create tasks there. And so now we've got a couple users here. And again, we've got our end-to-end run. If I do execute this, runs will show up. And the different information. I'm trying to run this now, actually, and see if we can get the information. But again, I've got my single run, and then it will show individual pipeline steps. Hopefully all three of these will go through, and then it will go from ingestion to prediction, and then doing that. But all steps that we've worked through in today's lab will be, put into this pipeline, this workflow, and executed in order here. This is probably going to take a little while to go because of the need to spin up a jobs cluster. So we won't necessarily wait for this to finish, but ideally this will move through all three steps, and we'll have a complete idea and timing around what individual steps took, and then the total run there as well. Mark asks a good question. There is not currently version control with dashboarding or underlying objects. It's a feature that we've got in requests for to be able to add. There's not direct repo integration as well. The SQL objects and the visualizations, the dashboards are all kind of just custom objects that are stored into the SaaS layer of Databricks there. So something that we're working on, I believe, for future release. You can specify multiple dependencies. That would be as straightforward as, if I can go back to my job here. So in this case, if I wanted to do multiple dependencies here, I could select step. And for instance, if I just select an arbitrary notebook, so say that this was working and I could do my Unity catalog notebook here. It'd be a matter of having that step and then saying it depends on, and then I could select, multiple dependencies there. Again, that should adjust and handle that. Someone's asking what I refer to as the SaaS layer. That's the software as a service layer. So again, this whole interface is part of the Databricks solution that's hosted by Databricks, all the development plane, everything like that. The VMs, the underlying data is hosted in your own data tenancy. And then the control plane, as we call it, is the software as a service layer. Sorry for the lingo there. But again, we manage the whole front end of this, and then the back end, the data, the actual compute, large in part will reside within your own cloud data tenancy. There's a question around the orchestration code generated from UI. It is, in this case, all generated from UI. We do have APIs that can do that. It is something that we're actually working on currently, kind of composable. There's, for instance, there's a lot of Terraform ways or Terraform objects to be able to compose and version control your individual Databricks objects through code. We do have an SDK that can go out and be used inside of, say, an IDE rather than a notebook. And then workflows as code or workflow kind of composable workflows is an emerging features, but it's not something that we have currently released. And yes, you absolutely can schedule a workflow. And there was also a question around parameters. There's an ability to do with parameters as well there. Adding the ability to schedule and trigger, so you can do event-based scheduling or time-based scheduling here, being able to do that. I'm going to cancel this and see if my run is completed. Looks like it's still waiting for job compute to come up here. So we can tackle some more questions. Someone asked how you can see the associate data lake created. I don't have access into the Azure portal, but if you went into your Azure portal and looked at in this tenancy, you would see VMs associated with the clusters there. You would see Delta, the physical manifestation of the Delta tables, which is like a directory with some Parquet and log information inside of ADLS Gen 2. And so that's kind of how those things manifest inside of the data lake there. There's a question on notebook scheduling. Will it run with serverless? Serverless notebooks is, again, an emerging feature. Right now, serverless is pretty much just for the workflow code is emerging as a serverless option, and then SQL, the SQL runtime was our first serverless option, but as far as the individual notebooks, they will require jobs compute or interactive compute to do that. And again, we're trying to put more things into a serverless runtime, but that's something that's under happy development.
The latest technology.
There's a question around AutoML, around what fields had the most weights. Yes, that I believe is part of an AutoML generated notebook, where you can go in and do some analysis. As it hits the model, it'll pop the model with the best metric that you specify. We used F1 in our example, but it will try to do that. And then as part of that notebook, you can go in and actually see the feature significance as part of that. Can schedule the workflow. And yeah, for all those folks requesting a recording, I do believe that a recording will be made available there. Someone asked how to create a jobs cluster. There is not necessarily an interactive way to create a jobs cluster. Jobs clusters have a kind of a cluster policy assigned to them. So a framework for how they are created is done. But the idea is that they're only created at job execution time. So a job cluster is given kind of a format. We specified a job cluster policy as part of this execution. And then they're created, and then they can be persisted across the lifetime of a workflow. But the idea is that they're started up and shut down as quickly as possible. They don't have persistence. They're not used by multiple jobs. Or multiple independent jobs. They're out there just to service the job and then shut down. Specify multiple dependencies. There's a question on accessing Azure storage from Databricks. We do have, I don't know if this is part of the flow, but we do have the ability to define in Unity Catalog locations. So the ability to access external data here. I don't have this necessarily set up, but the idea to be able to specify an external location, which given a storage credential and a name, might be an external bucket or something where you want to give users direct access to land data there, to be able to play with data there. So we create an external location here, and then in the catalog, I believe there should be the ability to add a volume. Volumes are a new object inside of Unity Catalog, but that is the idea, is that there's a way to access unstructured data. If there's image files or media files that you'd like to integrate into your pipelines, we do give a modicum of control to those volumes, which are mapped down to blob storage, but they're referenceable, and again, you can assign permissions to the volume itself, so you can make, without giving users direct access to the underlying buckets, mapping the bucket up, giving it permissions inside of Unity Catalog, and then your notebook users can access different files inside of those volumes there. I believe this question on billing, I believe it is down to the minute. So there's a rate on the individual compute that you can see here. For where's my cluster? To give you an idea, we've got, in this case, the way that this cluster is scaled, it does give you an idea that there's going to be 0.75 dBUs. That's the kind of the volume, or the standard unit, the Databricks unit that we charge, that's abstracted away. There are different rates for different DBU types, and I believe it's down to the minute with regards to how long you have the cluster up. We charge based on how much compute is used in that amount of time. Someone asked the question if volume is compatible with autoloader. I don't believe so. Again, autoloader is going to be giving kind of Delta table oriented functions. So the ability to infer schema information or data types or things like that from semi-structured data. And, it tries to take its best hack at like structured JSON and things like that. You could auto load from files that are in a volume, but as far as landing stuff in there with autoloader, it's mostly to load into Delta, I believe. Pravin, if that's the question you're asking. Okay, so it looks like Christian, I believe you called out. I selected the 2 notebook, and I should have selected the 2.1 notebook for that scheduled job, which actually takes the model and does our batch inference on the table there. So we're not looking to retrain the model. We're looking to use batch inference to enhance the table. Thank you for calling that out. Derek's asking the question, where do you register MLflow models if you want to register with Unity Catalog? I believe that, actually a good question. So the various facets of MLflow are kind of being integrated into Unity Catalog. Not everything is there yet. A big push right now is to have feature stores brought in. I don't believe that models necessarily have like first-class citizenship inside of the Catalog Explorer here yet. Yeah, so short answer to your question is I don't, there is a way to have these tracked in here somewhere. I don't have the code with regards to this demo flow to have that inserted in there. Right, I guess we're just in the last 10 minutes here in kind of Q&A time. So I'm going to pause my sharing of the lab and switch over to the go away information. Do this correctly. So our key takeaways here, again, I think that there's maybe a day time limit, or there'll be this lab environment will be available to everyone attending here through sometimes today or tomorrow. But taking from here, you feel free and please do use the QR code or the link. I don't think you can see the link, but we'll be providing a link to the Azure Databricks 14-day free trial. So in a way to get in, have your own environment, to be able to load data, to work through some of the things here. Certainly that Git repository is part of our demos, the Lakehouse Labs, so that it will be available, well past the thing here if you want to try to replicate what we've done with regards to that. One of the nice things about the lab is it is all that random information that we generated at the top. That's completely reproducible inside of your own environment. So if you'd like to go through that, work through it again, work through some of the steps that we did there, that demo, as well as many other demos, excuse me, I'm talking too much. That demo will be available, as well as many other demos inside of that Databricks demos GitHub repository are available for you to play with and to take and use there. Let's see if we got any more questions coming in. There's a question around moving data from ADLS to Delta. That would just be kind of exactly what we did. We landed raw data in JSON format inside of ADLS. That was the location we were working in there. And then we transformed it using autoloader into a Delta table. So I think Arthur's probably answering along the same lines there. Thank you for the comment around the demo. DB and Selden. I don't know Selden, unfortunately. I don't know if anybody's familiar with. I don't believe we offer any kind of formal support outside of what you can access with your free trial. The code is just kind of presented as is to be able to use in your environment there. There's a question around moving data from Synapse. Yes, we have the ability to, migrate the runtime there. The underlying tables, and it's kind of data dependent, but to be able to migrate data from Synapse. But again, those are kind of talking about different Microsoft first-party features there. So it's really, if you want to tap the additional things, you could use Synapse as a source and pull data in to Delta Lake to be able to do some of these downstream processing things. There's a question around multiple domains, finance and healthcare, using different workspaces. That it's a pretty popular methodology to do that, to delineate workspaces. We also see, folks putting different workspaces for maybe dev test prod or, dev staging prod, something like that. But then it really depends on kind of identity and who you want to be able to give data in what workspaces. So if you want to delineate and say, I want to only have finance users accessing finance data, you would just want to grant them into that workspace. That's an easy way to do it. It's also an easy way to understand costs with regards to how much compute is being used. It's very straightforward to map how much compute is used inside of one workspace. And then so that's a popular way to do that. Organizations, IT spins out many workspaces and then might put it like a cross-charge model in place to say, to encourage responsible behavior inside of the different workspaces with regards to data size, leaving compute running, things like that. We're not escaping the underlying need for responsibility inside of cloud infrastructure management there. There's a question around how's the technology framework used in Amazon and Google Cloud. It is similar. We use the underlying fundamentals of object storage and virtual compute. So EC2 and S3 in Amazon and the Google VM and Google Cloud Storage in GCP. It's kind of their different manifestations. Azure, interestingly, is the one ecosystem that we are a first-party product in. So we're able to go in and integrate a little more directly. You can go into your Azure dashboard and click Azure Databricks as if it were a first-party service there. So a little bit different flavor there. But again, underlying networking, the kind of the compute VM and object storage are 1-2 punch of how they manifest themselves in the different cloud ecosystems. There was a question, can we load from the cloud layer, the gold layer, to a database? Yes, that's actually a popular way to make manifest. So, if the gold layer is a cleansed table and you don't have anything interesting going on with regards to the underlying data structures or anything, you could certainly load that into a SQL database. We've got customers that want to power data that's being engineered into the platform, but then they want to give microsecond level loads. They might put it into a document database or something to power a web app. There's various features. We've got great plug-in capabilities to be able to load data maybe out of the gold layer or replicate it into a database for that consumption layer speed there, depending on what the requirement is. There's the question around the overview of Unity versus the Hive Metastore. So as I mentioned, the Hive Metastore, based on the Apache Hive project, metadata management, and kind of our legacy model. What we decided to do, Unity Catalog is a Databricks developed product, and we took the two-level namespace. Essentially, you have a Hive Metastore, and then schemas underneath that, and tables. And propagated it up one layer. So there's the ability to have multiple catalogs or multiple kind of instances of what the Hive Metastore used to do. but that we've expanded on it to allow more fine-grained access control with regards to table ACLs, access control lists at a basic sense. There's also the different object management, so being able to pull the different things in there. It's allowed us to put things like lineage, a lineage service in there for title control again. So just kind of a superstructure, being able to allow multiple iterations of a catalog. One thing that also provides is better identity management. So with Unity, identity management goes up to the account level. And so you can create a user one time or sync a user with single sign-on one time, and then let that propagate down and give that user different permissions within different workspaces before every user that needed to be given permission needed to be given permission to each individual workspace. And then the permissions would flow from there. So again, it allows us for a higher level identity at your account over multiple workspaces, and then more flexibility with how permissions are doled out, where things are located physically within the actual manifestation of that metadata management layer. Yeah, you should be able to use the same repo. That's just a Databricks demo public thing, so you should be able to pull that down and do that. There's a question around PHI, PII security. So Azure and Amazon, we both have kind of secure compute options where we enforce encrypted compute. We give HIPAA compliant options there. So there's some more image hardening with regard to the cluster, some additional things, active malware scanning and things like that. There are some options there for sensitive data to do an extra layer. We're also moving into trying to get FedRAMP certified. I don't know the exact status of that, but there are GovCloud versions of this that allow for that extra layer of security control there. All right, we're at the top of the hour. I guess we would love to have your feedback. So please, if you could take the link here, snap a picture of that QR code and give us your feedback. We're constantly trying to improve these sessions. We appreciate your attendance. We appreciate your attention, and any feedback that you can provide us here, please hit us at that link and give us your honest opinion about today's session. Thank you very much. Shamlin, anything else that I'm forgetting?
No, I think that's it. Thanks everyone for joining, and you can expect that follow-up email with all the assets from today, probably in your inbox tomorrow. All right, thanks everyone.
Thank you.